Assalamualaikum and good morning everyone. My name is Alawi. So today I will be presenting about the Setiawangsa Expressway, also known as Duke Phase 3. So this major highway project is one of the most important development in Kuala Lumpur's traffic and also infrastructure system. The Setiawangsa Pantai Expressway are formerly known as Duke Phase 3, which stretches to approximately to 29.8 kilometers, and it was opened fully to the public starting from 3rd November 2023. This project was developed by the Lebuh Raya Duke Phase 3 Sdn Bhd, a subsidiary of Ibu Phase Berhad. The expressway starts at Taman Melati in the north and ends at Kerinci in the south. It connects several key areas such as Wangsa Maju, Taman Melati, Bandar Malaysia, Pantai and also Ampang. The SPE is built mostly as an elevated expressway with single-decker flyover sections, and it features dual carriageway with 3 lanes for each direction. So the main goal of SPE is to ease the traffic congestion and improve connectivity across the Kuala Lumpur. However, the construction faced several challenges including delays and realignment because of COVID-19 pandemic. And there were also concerns from the residents about the noise and pollution, and also the initial traffic was lower than expected.
Assalamualaikum. So today I'll be presenting about the main elements and also the materials. So we have 4 types of elements, which is piers, abutment, deck and also beam. So let's start with piers. What is piers? So piers are the vertical supports that transfer the load from the deck to the foundation. As you can see at the figure above, where the piers is located under the deck. So that's the function of piers, where it supports the deck. Also, the materials that are being used by piers is actually reinforced concrete and also steel. So why does it use steel and also concrete? It is because they provide stability and also support for the bridge, especially in the areas with verifying geotechnical condition. And also, during the construction, false are being used. The second element is deck. So what is the function of deck? Deck is the surface that allow vehicles and also pedestrians to travel. And also, it serves as the part that transfer the loads to the piers. As you can see in the figure above, there is where deck is located on the piers. Also, it is made from high performance reinforced concrete with a durable mix to withstand urban and also geotechnically sensitive environments. Also, the decks are typically supported by precast beam or cast into concrete slabs. Next, what is abutment? Abutment usually located at the beginning and also at the ending of the bridge. So it is usually to support the structure and also to transfer the load to the ground. The fourth element is beams. So beams support the bridge deck and also transfer the load to the piers and also to the abutment. So the material that is being used to make beam is precast or in situ concrete beams are commonly used. Also, there are several types of beams, which is precast beam, post-tension beams, and also the Dura UBG girders that usually is needed for long span.
My name is Maizati Rudani. So the method is begin by doing the pre-construction stage, which include the planning and design, site investigation and site preparation. Then it is time for the foundation and substructure construction, where the board pile is set up as the piling. The foundation process begins by excavating the ground to the founding level. Setting out must be done since it's a critical step in this method. Board pile are installed by drilling the soil to the required length, which is 20 to 40 meters depth using the board pile rig. Reinforcement cage then placed into the hole and concrete is poured. Next, pile cap is installed on top of the board pile. There will be excessive concrete, which it should be bricked into a specific length to ensure the pile cap surfaces is smooth. Reinforcement steel bar are placed and the spacing and anchorage of reinforcements must be ensured. After done the pile cap, abutment will be constructed by doing the excavation first. Pile foundation will be installed as the support for the abutment, and blinding concrete is constructed to prevent contamination. Rebar cage is placed for pile cap, then the same method will be done to the foundation. For the foundation, for the abutment wall, vertical and horizontal rebar are fixed together. There is a back wall for the abutment, so the wall will be extended from sides of abutment and constructed in same way. As for the backfill, selected fills such as granular or sand are used to compact. So layer by layer will be compacted using the compactor, while drainage layer or whip holes will be installed together. Next, pier column. It is formed by tying the vertical rebars from pile cap and extended outwards. For confinement, horizontal or stirrups are applied. For pier head, or known as the transom, it was viewed after the pier column is cured. Before this work begins, temporary support such as falsewood, which used in this project, must be applied to hold as support to the piers. Then concrete pad is constructed by installing it on top of the transom, which it acts as a leveling base for bearing pad. Transom top is cleaned and chipped to expose aggregate. Non-shrink grout or high-strength mortar may be used. After concrete pad, bearing pad is installed. It will be lifted using cranes and positioned on concrete pad. Anchor bolts or studs will be inserted to recesses which 50 millimeter wider than the anchor bolt diameter. So the gaps is filled with high strength and shrinkage composite grout compatible with concrete substrate. Now, superstructure construction begins. In this project, they use precast girder as their main element. The precast girder used is the BH girder. It was cast off-site and transported to the site location. Then it will be lifted using the launching girders, which spanning up to 62 meters. In this process, falsewood is used to support the beam as the precaution. Then the beam secured on the bearings and connection between beams and deck slab are prepared for composite action. The duration of this process is taken 1 to 3 nights per span. After that, case in situ reinforced concrete decks are constructed on top of the beam to form a composite bridge deck system. After every element have been completed and cured, installation of parapet, median and side barriers, utility ducts, street lighting, and drainage system will begin. Road works will take place after the deck construction is done, and finally works and tasting such as inspection will follow.
Hi everybody, my name is Wafino Fal. We're at this video with the design challenge. One of the major issues faced was the extremely tight urban space. In some areas, the beam bridge was constructed less than 2 meters away from residential intakes. This meant that traditional fossil setups couldn't be used without causing disruption. So, engineers had to use compact and modular system that could fit in tight spots without blocking roads or entrances. Then another challenge was safety in congested area, especially since most of the construction happened in busy city areas like Jalan Turaza and Jalan Jalatik. The cars, pedestrian, and existing utilities nearby also had to be installed and removed quickly, often with off-peak hours to minimize risk. Next, structural stability over crushed ground. The ground condition also created problems. The road sits on livestock cars, which means the soil is uneven and causing cavities. So the fossil foundation had to be specially designed to stay stable, using load distributing plates and adjustable shoulder system. And the last one is speed and precision. Beam installation had to match tight deadlines to reduce prolonged road closures and public inconvenience. Power systems were designed to allow repeat cycling like selection, use, and removal in very short periods. Alright, now moving on to the technological attactions. To reduce time on site, the project used prefabricated falsewood components. These were built off-site and simply lifted into place, which made the process faster and safer. They also use adjustable falsewood system with hydraulic jacks. This allowed workers to fine-tune their height during installation, which was really helpful on uneven ground. Instead of using traditional timber, they use lightweight materials like aluminium and high-tensile steel. These are easier to handle, reusable, and more eco-friendly. And finally, they use building information modeling, or we call BIM, to plan the layout of the falsewood digitally. This helped avoid crashes with utilities and improve safety. Some systems even had sensors to monitor stress level in real time. In summary, the SPD project faced serious design limitation due to its location and ground condition. But through smart planning and technology, the team was able to react efficiently while protecting both the environment and the public. Thank you.